How are we doing today? Darren, you're really obsessed with Kahoot music, huh? Maybe later when you're working, then I'll play Kahoot music. I feel like in the morning you need to relax a little bit. So, as you know, um, we are not going back to school this school year. So, yeah, gonna be like this for the next 2 months, pretty much. Hi. So if you if you haven't printed this out yet, go print this out, or if you just want to do free notes, that's fine too. I know, right, Matt? The sadness of not seeing you guys again this school year is crazy. This printout is in locker on School Loop. Yes, it's under note guides. No, I'm not waiting for breakfast. I'm just ready to go when you guys are ready. Not eating. So I'll probably eat after this. Okay, so ready? Okay, so today we're talking about segment relationship in a circle. The difference between this one and the previous one, so the previous section we talked about angle relationship, right? So we're going to talk about segment relationship. What are segment relationship? Well, let's talk a little bit, okay? I'm going to move this slightly to this way. Okay. So explore segment relationships in circles. This is, we are having 3 different situations. Okay. First one is inside, then outside, and the last one is tangent. Okay. This is the 2nd of April. Need to make it slightly higher, maybe. Okay? How are we doing? All right. So, as you can see in the picture, it looks almost identical to the previous lesson we had, which is angle relationship. On the previous lesson, we talked about how this angle is the average between these two arc measures, right? Today, we're going to discuss about the relationship between these length on the segment. You see this length? These chords, they have length, right? But they're related, okay? So here, let's examine what this is, okay? If it's inside, okay, this intersection right here, then AE times EB, these two multiplied together, is equal to CE times ED. I'll change the color. Oops. CE times ED. Yeah, like that. Now, why is that, you might ask? So let's explore this further. So, let's discuss this by drawing two lines first. Let's draw this line and this line, okay? These two lines. Can you tell me what is the relation between these two triangles? What is the relation between these two triangles? The two I just highlighted. They are, to prove congruence, you have to have size congruent, but the size you can't know for sure, right? Not side angle side, not congruent, because what I'm looking at is I'm trying to show you why such relationship work. So Ditya said they're similar by AA. So can you tell me which two pairs of angles are congruent? Because AA requires two pairs of angles, right? So one of one is more obvious than the other. Which angles are congruent? A is correct, but you need to find two pairs of angles that are congruent. Which would it be? Which would it be? Oh. Okay. So Aditya pointed out an interesting one that is not as obvious. Which is great, because that's the one that's harder. So the first obvious one is the vertical angles are congruent, right? These two angles are congruent, very good. These two angles are congruent, right? That's the first thing, it's called vertical angles. The second pair are C and B, which is, actually you can do AD or CB, doesn't matter. So I'm just gonna do these two because it's easier to draw here versus here. These two are also congruent because look at where these two angles are formed. You see how like these two angles are both of the same arc, both inscribed angles, and we said inscribed angles is exactly half the measure of the arc measure. Since that's the case, then these two angles must be congruent, right? That's from 10.4. Okay. And since that's the case, you have angle-angle similarity. Does that make sense? But what is interesting about angle-angle similarity is that because things are similar, we can basically say, see, AE to AE to CE, this to this, right? AE over CE is equal to DE over BE, EB. Okay? This is true because proportional, right? These are proportional. Or you can do this to this is over this to this. However you want to set it up, and then you cross multiply, and you get this relationship. Okay? So that's number one. How are we doing? So, the rest is very similar. I'm gonna quickly go through this, and I'm not gonna prove every single one of them because it's a little bit too long. So I'm going to show you basically how they are, and hi Ryan, and then we'll go from there. Okay, so look at this. So the next few, I'm just gonna mark the theorem real quick, and then we are going to talk about how to remember them. All the proofs here are very similar. If you're interested, you can prove it yourself, or if you're interested, I can show them in the office hour too. Just send me an email if you want to see it. Okay, so AE. Oh, okay. So next few looks like this. EB times EA is equal to ED times EC, like this. So this is the outside situation. It might look different at first, but they're all the same idea when you're trying to remember them, and I'll talk about them in a bit. Okay, how to remember them, because sometimes it's a little bit more difficult to remember them if you don't have a pattern, right? So next one is CBCA times together is equal to CD squared. Okay, so these are the theorems. Now we're going to talk about how I remember them, because when you apply something, it's important to consistently be able to get the right system right? Because you don't want to keep having to come back. Okay. So that being said, let's take a look at these three. Okay. So every time, so there are three situations. Okay. The first situation is called inside. Right. This is inside, and this is outside, and this is tangent. Right. Three different situations. Okay. So then, what we want to do is always identify the intersections. What intersection? Two lines, right? Two lines intersect here. See that? What about these two lines? Where do they intersect? Right here. What about these two? Right here, right? These are intersections of the two lines that we're identifying. Okay? This is essential. Once you get this intersection, then you can start writing your equation. So it goes like this. Watch. Start from the center, okay? Start from the intersection, not center, intersection. Pick one line, okay? So it's this times this, okay? And then the other line, that times that. They're supposed to be equal. Okay? So, next part. So it's intersection to the edge of the circle, okay? It's intersection to circle, intersection to circle, intersection to circle, intersection to circle. Okay? Similarly, let's look at this. this is an intersection, right? So intersection to circle, pick a line. Okay, I'm gonna pick this line. Logan, no, everyone's saying hi, but we're gonna retake attendance in a bit to formally confirm everyone's here. If you haven't said hi, that's fine. But I mean, you kind of already did, so it doesn't really matter. No. We're gonna formally take attendance in a bit, okay? In a bit. It's okay. 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 So intersections here. Pick this line. Is this so intersection to circle times intersection to circle, which is the whole thing. Okay, don't go like this. Okay, this is a common mistake. This times this. Okay, that's not it. It's this times the whole thing. It's equal to intersection to circle, intersection to circle. Okay, like that. Last one is interesting. It's this, once again, circle to the intersection to circle, intersection to circle. This part's the same as the previous one. But the tangent part, it's this part square, right? How did I understand that? It's the same thing. Intersection to circle, intersection to circle, twice. So it's this times this, which is times itself twice, right? So it's squared. Okay. So it's all the same pattern to me. Okay. Intersection to circle times intersection to circle, intersection to circle. Is that okay? Ready to practice with some? Okay, so let's look at a question then. A problem. So this one, if you look at how they are, you can see here that they want to find this value, right? X, J, H. So because of that, you want to identify the center, which is J, and you go, okay, I'm going to pick this side, okay? So 14 and, so intersection to circle, 14 times X. 14 times X equal to this one, 7 times 10, okay? So then X becomes, so 14X is 70, so X is what? 5? That's that right? Try the right side real quick. All right, final answer yet? Should be quick, right? What's the answer? So these two multiply together. So you go to who's echo or icho. So 8x is equal to 30. So x is equal to 3.75. How are we doing? Good? Make sense? It's good. All right, let's look at these ones, which is outside. Okay, so just avoid common mistakes about like doing this. Okay, it's not 8 times x. Okay, and 7 times 9. So first of all, you have to identify that you need to do this, right? The whole thing. So it's hi Alex, welcome back. 7 times 16. Okay, 7 times 16, because the whole thing is 16, right? So 7 times 16, all right, 7 times 16 is equal to 8. What's the whole thing here? How do I represent that? This whole thing. A plus x. So put a plus x. All right, and then you distribute and solve. So here, b1, 1, 2 equals to 64 plus 8x. So you distribute, right? Remember how to distribute this? This times this, this times this. And then move this over. So 48 equals 8x. X is 6. Okay. Let's do one more together on the bottom part with the tangent case. This one. So similarly, this one, intersections right here. So you go intersection to circle, intersection to circle. Intersection to a circle on the other side is what? 5 plus 15, so that's 20. So it's 5 times 20. The other side is a tangent, and we do the double, right? So, oops, equals x squared, right? So then, 100 is equal to x squared. So typically, x here will become plus or minus 10, but we're doing length, so it's just positive 10. Okay? How are we doing? Equals 10 is correct. So if you're okay, let's try these two on your own. And then I'll take a little bit of attendance. I don't know what that means. I'll take attendance real quick, and then I'll go over this, and then we'll go over some housekeeping items. Okay. Can you guys see if you don't have a hard copy of this? Yeah, I think this is fine. All right. So, here we go. Okay, if you are here, type here right now so that I can count everyone. So looks like we don't have everyone, so I need to go over it in a little bit of time. Keon, are you here? Keon's not here. Anissa, are you here? Okay. How about like Kina? Kina's you? No? Okay, so the rest of people seem to be here. I'm missing Anissa, Kian, and Kina. Okay, so if you're watching the video, please remember to comment under the video, or you can email me the comments about the lesson so I can take your attendance. Okay, do so before today, before 3:45. Okay. All right. So let's talk about the problems. All right. So look at it real quick here. So the first one is, you gotta set it up, right? So you find the intersection first. Okay. So intersection is here. Oops, too close. I'll pull it up a little bit. So okay. So this is the intersection, so I'm gonna set it up. 9 times the whole thing here. Oops, I can't draw. Whole thing here. So it'll be 9 times 39 is equal to, same thing here. Okay. Will be this 13 times 13 plus z. Okay. And then you can simplify first, or you can multiply out all the way. So you can cancel out the 13 and 39, divide by 13 both sides, so you get 3 left. So 27 is 13 plus z, so z is naturally 14. Okay. Last part. 7 plus y, and 10 times 10, right? It's 10 squared. So 49 plus y, 7y is equal to 100. So 7y is 51. So y is 7.29-ish, right? You round it. Are we clear on this one? Any questions about this? Just be careful with the outside angles. That way you can set it up correctly. Okay? All right. So did everyone sign up for the big ideas thing yet? I'm trying to get everyone in so that you can do the homework. The only homework this week is on big ideas. So I'm gonna go to, when you sign up, you have to use the code I give you in the email, okay? Otherwise, you'll all be in period 4 instead. All right. So go read my email, watch the video on how to sign up. Okay. For those of you who signed up this morning or yesterday, I may not have added you to the assignment yet, like Mayho, Ava, Alex. So now I'm adding you to it. If you haven't added yet, if you haven't signed up, go sign up right now. Okay, go sign up right now. For the rest of you, you can start doing the homework. I want to take care of all the login business right now so that you don't have to worry about later. Okay, so if you are done with this, you're okay, and you already signed up, you can feel free to log off of this stream. But if you want to stay, you can stay, obviously. But I want to make sure everyone knows how to sign in to Big Ideas and take care of any of those questions before you guys go to do your homework, okay? Because I do need to manually add you to the assignments. So if you just signed up and you can't see the assignments, just let me know, okay? Then I'll add you, okay? When did I send the email? Like Sunday or Saturday, something like that. It's the email titled changes to homework submission or something like that. Geometry. Loop mail. If you still have chapter 9 test corrections, you can just send me the pictures and I'll update your I'll update your grades. Didn't I pass that back? I think I did. Is there a video to sign up on your Wait, is there a video to sign up on your channel? You mean like the loop mail? The big ideas? There is in the loop mail I sent. It's titled, if you didn't read my email at all, I'm just gonna tell you how to get to it, okay? So because it's like very simple if you just have a code. So here, let me send you the code. I'm gonna upload the code here in the chat, and then you just go to okay. So let me type it here so that we don't have to keep on looking at it. Okay, it's also in the email, but I'll put it here. I'll put it here. It's in the email. But go to bigideasmath.com. Okay. And then you're gonna sign up, right? When you sign up, this is the access code. So Hannah, your question about notes, we are going to turn it in later maybe, but not right now, because some notes I feel like, you can just use for yourself, but we might have a different system turned. The whole reason why we switch it up is because a lot of people have problems uploading multiple photos onto School Loop, and if you send me individually, then I have like 30 emails per class just for the assignment, and I have to look up every single person. So it's too difficult to do it that way. So I want to have a better way to keep track of things, but I don't want to use another another like a Google Classroom type of platform, because then you have to keep track of everything. It doesn't let you click on assignments tab. Let me see. Okay, I just got a bunch of signups. So I've just added all you guys. So Mayho, try refreshing the page, see if it works. Archita, to answer your question, we're still waiting for some district policy on how grading works and how our tests and quizzes work, because now we can't have a lot of high stakes tests anymore. I don't know, log in to see if you made it on, and then see if you can see the assignments. Still doesn't work. Let me see. Should work. Which one did you click on? So there should be an assignment that says 10.6 assignments. Okay, I just got a bunch of more signups. 1 sec. You can't log in. What? Does it show now? So if you just sign up and you can't see it's normal, but Mayho, you should be able to see it. Let me see. You can't click on it? Let me see you. So which page are you stuck on, Mayho? Your username is incorrect. It's because it probably is. Let me see. So for Ditya, your username is this. That's your username. Who needs their username that you didn't remember? Didn't it post a username there? Let me see. Ari, you need your username. Yeah. Let me see. Ari, this is your username. Let me see if anybody else signed up. I haven't taken care of. Okay, I got more signups. Let me see. So, it didn't let you sign in. Did you like use the wrong username by any chance? Let me see. The username they gave you usually is not saved for some odd reason. Matt, here is your username. Use this one. Mayhel, you're still stuck? You can resubmit a different answer. You can. You definitely can. Let me see what you have. Mayhel. So you did log in through the 003 username, right? Hold on, let me see if you're double signed up. If you are, then I can... Wait. When you check your answer, doesn't it tell you right or wrong? Joseph? Let me see. So, you were able to click on resources last night? Interesting. Okay. Are you on the browser right now, Mayhel? Wait. Okay. So, do you know how? Are you on Chrome or you're on what kind of browser do you have? What kind of browser do you have? Chrome. Okay. So go to history. Okay, go to history. And you see a tab says clear browsing data, right? You see that one? Or actually, you can just open up an incognito window if you know how to do that and see if that works. If not, go to your history and try to clear cookies and other site data. Sometimes cookies mess with it. Sometimes. May or may not solve your problem. Do you find where it is? It's under clearing browsing data. And under, you don't have to clear your browsing history, you just need to clear the cookies and stuff. And then re-sign. See if that works. Dia, are you in yet? Oh wait, when they clear data, sometimes they log out of this window too. So, I'll wait. It's fine. Anybody else have any questions, problems on this? Good. Anybody else have problem accessing? There's only one, yeah, 10.6 homework. That's the only one. 10.6 homework. Joseph, you did manage to change your answer, right? That's good. Good. Oops. Anybody else have problems today? Mayho, are you back? Goodbye. If you're good, you can go. Got it. Bye. Homework's 10.6, homework on big ideas. So once you log in, you should be able to see the assignment by clicking on the assignment tab. You see it, Anjali? Got it? Are you able to see the assignments? Okay, good. Mayho, are you back yet? Okay. Anybody else have any questions before I sign off? If you have any more questions, hit me on Remind, hit me on email. But if not, I'll see you in office hour. I'll explain some of the problems in office hour as requested already. So if you want to tune in, you can at 11 o'clock. Okay? Goodbye.